Hello. This will be a little update on the wireless oscillation. I made a few changes on the circuit. I'm now using two lithium-ion cells, 3.7 volts each. Gives me about 8 volts maximum. I've changed the 2N22 to 2 for 2N3055. The oscillator here, it's still with 2N22 to 2, but with a different coil. It's a bigger coil, same size of the wire here, but with less diameter. Is this coil here. Now I have 5 LEDs in series, 4 in here. I've changed the resistor on the base and put 2 potentiometers. I'm trying to find a way to use light, really to use these LEDs to light up things, like this one here. This is Casper. Casper is running on my alum LED cell here, and he stays in my stairs for me not to fall off the stairs, and he stays on for maybe 3 days. Today's the 3rd day he's on. Okay. As I'm trying to light up things in my house, I want pretty bright LEDs. So here's too much. Here is 200 milliamps. 200 milliamps. I have 4 LEDs in series here. On this, this tape is just to fix the receiver and the transmitter, the same before. Another one here, and with this other coil I'm trying to find more places to get more light. So I just like to show where you can get more light with this kind of coils. There is a place in here. See, let me try to. Oh, it's better now. There's a place in here. We are now with 20 milliamps, 19. Here you can see the LEDs glowing. But I don't want glowing LEDs. I want really bright LEDs. So as I close up, we are counterclockwise, I mean opposite sides on these 2 coils. As I approach here, there's a spot here. I do not affect these LEDs or these LEDs. They are all the same bright, and the amps draw 10 milliamps. Now we are with 18. If I get here 19, I come back to here 18, And if I approach a little more, it begins to decrease the lights on this oscillator and also the amps from the battery. See, now it's almost off. 16, 15 milliamps, but the lights in here are almost off, so there is a spot here, 18, where I can get more light. I can put more LEDs here, maybe in series or in parallel, I have to test, and 10 milliamps less from the battery. 19, 18 here. No changes on the circuit. All the lights are the same. 10 milliamps less in the battery. Very strange, but it works. But if I put here on the same size, the same direction of the transmitter coil, look what happens. 19, it's glowing, still 19, still 19. I can have more light with 19, the same amount of amps from the battery. Nothing changes in the other lights. So, which one is better? More light inside the coil with the same, or in the opposite direction? More light from here with 10 milliamps less. You decide. I prefer 10 milliamps less. And here on the receiver coil, there is also a spot here. Nothing changes on the circuit. Just a little ring on the transistor, and we can get the light from the coil receiver. Inside the coil receiver, opposite side of the coil receiver. So there are 3 spots to try. One closer, opposite direction, 18. Another one, opposite direction of the transmitter coil. Same direction of the transmitter coil. Inside, and or same direction of the receiver from inside. See, if you cross a little more, almost between the two, you also get the same effect. You get 10 milliamps less from the battery. Nothing changes on the circuit. But if you cross a little more over the lights here, so there are a lot of spots to explore here. I have 10 milliamps less, more light, nothing changes on the circuit. Here, same amount, 19 milliamps, more light, nothing changed on the circuit. And here oh sorry, opposite direction. And here 10 milliamps less from the battery, more light, nothing changed in the circuit. If you cross a little more, the light here is over. If you get a little more, 19 milliamps, the same. So 10 milliamps less, more light. And here, oops, and here, nothing changed. Opposite direction. Nothing changes on the circuit. On this spot here, the transistor is ringing a lot. He increases the frequency and even more. So on the coil receiver, opposite directions of these two coils, you can get light, nothing changes in the circuit. And on the same direction of the coil receiver, there is that spot that you can lower the amp draw. Here, 18 milliamps. I wish I can have another coil to try this one and this one. Maybe it's another test. $18 milliamps, nothing changed in the circuit, and less battery consumption. See, same direction of the coils. Yeah, it really seemed to be an amplification effect. Maybe the magnetic field, they starts to, I don't know, I don't understand. But I know where I'm going to use my LEDs. Okay, I hope we can find more places to get more light with less consumption. Like this, 19 milliamps, 18 milliamps, 19 milliamps, 18 milliamps. Well, that's what I'd like to show. Okay, thanks for watching.